Hello and welcome to our channel. Today we will travel back to the 1600s and meet a young boy named Isaac Newton. He grew up in a small village in England. His simple ideas changed how we understand the world. In this video we will follow Isaac's life step by step. We'll start with his childhood on the farm, move on to his school days, and see how he became one of the greatest scientists ever. This story is in simple English, so you can learn new words and enjoy the journey. Get ready to discover how a curious boy with a big mind saw an apple fall and changed physics forever. Let's begin. Chapter 1, The Early Years. Isaac Newton was born on January 4, 1643, at Woolsthorpe Manor in England. He arrived 3 months early and was very small. Many people thought he might not survive, but he grew stronger each day. His early struggle taught him to persevere. His father had died before Isaac was born, and his mother, Hannah, was only 27. When Isaac was 3, his mother remarried and moved away, leaving him with his grandmother. This separation made him feel lonely but also taught him to be independent. He learned to spend long hours on his own. On the farm, Isaac did simple chores like feeding chickens, bringing water to the cows, and sweeping floors. These quiet tasks gave him time to think and observe. He watched raindrops on leaves, followed ants in the dirt, and wondered why things moved the way they did. His farm life sparked a deep curiosity. At age 12, Isaac began to attend the King's School in Grantham. He lived with a local family and walked 5 miles to school each day. In class, he studied reading, writing, and Latin. Latin was the language of scholars and opened doors to important books. Isaac did not join the other boys in noisy games. Instead, he spent breaks reading books or making simple machines. He built a small windmill that could grind grain and a water clock that measured time with dripping water. These early inventions showed his interest in how parts work together. Some students teased Isaac for his quiet and serious nature, but he did not mind their jokes. He focused on his studies and experiments, determined to learn more. His strong will and love of learning guided him through challenges. When Isaac was 17, his mother returned and wanted him to leave school and work on the farm. He tried the farm work but felt unhappy without his books and models. He explained to his mother that he needed to study to follow his curiosity. Seeing his determination, his mother agreed to let him continue his education. In 1661, at age 18, Isaac went to Trinity College, Cambridge. He left Woolsthorpe Manor behind, but he carried his curiosity and quiet habits with him. These early years laid the foundation for the discoveries that would change science forever. Chapter 2, Cambridge and the Great Year. In 1661, Isaac Newton left Woolsthorpe Manor and entered Trinity College, Cambridge. He was 18 years old. At Cambridge, he found a world of books and ideas. He lived in a small room and spent hours reading and writing. Isaac studied the works of great thinkers. He read Euclid's Elements, which showed him the rules of geometry. He read Descartes on algebra and philosophy. He learned from Galileo's studies of motion and Kepler's laws of the planets. These books opened his mind to new ways of seeing the world. Each day, Isaac walked to lectures and spent long hours in the library. He copied notes by candlelight and solved difficult problems. He also built a simple reflecting telescope with mirrors and glass. This instrument helped him learn about light and stars. In 1665, a plague reached Cambridge. The university closed and students went home to stay safe. Isaac returned to Woolsthorpe Manor for 2 years. This time alone became the most productive period of his life. He wrote his first notes on calculus and began experiments on light and motion. At home, Isaac set up simple tools. He used a glass prism to split white light into a rainbow of colors. He saw that white light was made of many colors mixed together. He wrote about his discovery in what he called a new theory of colors. One day, Isaac watched an apple fall from a tree. He asked himself why the apple fell straight down. He wondered if the same force that pulled the apple might reach all the way to the moon and keep it in orbit. This idea was the seed of his law of universal gravitation. During these years, Isaac also worked on a new form of mathematics. He called it flux ions, but today we call it calculus. He used flux ions to describe how objects move and change. He wrote detailed notes on motion, speed, and acceleration. In 1667, the plague ended and Cambridge reopened. Isaac returned to Trinity College and was elected a fellow. He became a lecturer and taught mathematics to other students. His friend and teacher, Isaac Barrow, resigned the Lucasian professorship so that Newton could take the position in 1669. These years at Cambridge and Woolsthorpe shaped Isaac Newton's mind. His discoveries in light, motion, and mathematics built a strong foundation for his future work. In the next chapter, we will follow Isaac as he writes his masterpiece, the Philosophiae Naturalis Principia Mathematica, and changes the world of science forever. Chapter 3. The Principia and the Laws of Nature. After he became Lucasian professor in 1669, Newton started to plan a great book about the laws of nature. He spent many years working on his ideas. He wrote long notes by candlelight. He wanted to explain both motion and gravity. In 1684, his friend Edmund Halley visited him at Cambridge. Halley asked Newton why planets move in curved paths. Newton showed that the same force that makes apples fall could explain planetary motion. Halley was impressed. He urged Newton to write down his work. In 1687, Principia was published by the Royal Society. The full title was Philosophiae Naturalis Principia Mathematica. Halley paid for the printing. The book was in Latin, the language of scholars. It reached scientists across Europe. The first part of Principia listed 3 laws of motion. First, a body stays at rest or in motion unless a force acts on it. Second, force equals mass times acceleration. Third, for every action there is an equal and opposite reaction. These simple rules had deep power. In the next part, Newton described the law of universal gravitation. He showed that every 2 masses pull on each other with a force. The strength of this force depends on their masses and the distance between them. He wrote a clear formula for it. This law united the heavens with everyday life on Earth. With these laws, Newton could explain the orbits of planets, the shape of tides, and the paths of comets. His mathematical proofs were careful and logical. Scientists could use his formulas to predict new events. Nature seemed to follow clear rules. After Principia, Newton's fame grew quickly. Scientists wrote letters to him with questions and praise. He became a fellow of the Royal Society and later its president. He continued to study light and mathematics. His work changed the way people studied science. Newton's later years brought him honors and new challenges. He took charge of the Royal Mint and worked to improve England's coinage. He also studied alchemy and theology in private. His fame brought him wealth and a knighthood. Chapter 4. The Impact of Principia on Modern Science. Newton's Principia united 2 ways of learning about nature: careful experiments and precise mathematics. Before Principia, many scholars relied only on logic or only on observation. Newton showed that true understanding comes when we combine both methods into a clear, step-by-step scientific approach. By expressing natural laws with equations, Principia made mathematics the language of science. Scientists could now use numbers and formulas to predict how objects move. This change transformed science from a set of stories into a tool for accurate prediction and engineering. Principia's law of universal gravitation explained why planets orbit the sun and why tides rise and fall. It connected everyday events, like falling apples, with the motion of the moon. Later scientists used Newton's formulas to calculate the paths of comets and the orbits of satellites. Over the centuries, great minds built on Newton's work. Mathematicians such as Euler and Lagrange extended his methods, and 20th-century physicists like Einstein refined them. Even when new theories appeared, Newton's ideas remained the foundation for modern physics and engineering. Today, our world still runs on Newton's laws. From bridges and buildings to rockets and GPS satellites, engineers use his equations every day. The clear link between force, mass, and motion guides modern technology and keeps our understanding of the universe on solid ground. Chapter 5. Newton's London life begins. 1696. After accepting the Warden of the Mint position in 1696, Newton left the quiet halls of Cambridge for a modest townhouse beside the Tower of London. He arrived in a city alive with merchants unloading cargo at the docks, sailors trading stories, and scholars debating new ideas. Here, amid cobblestone streets and crowded taverns, Newton saw fresh challenges that called for the same precision he used in his experiments. At the Mint, he moved quickly from theory to practice. Newton set exact weight standards for every coin and introduced milled edges to make counterfeiting far more difficult. He spent long mornings inspecting silver and gold coins, noting even the slightest variation. In the afternoons, he walked through the bustling port disguised as a trader, quietly gathering information on illegal coining operations and building cases against forgers. Each evening, Newton retreated to his candlelit study, where he balanced ledgers and wrote letters to government officials and fellow members of the Royal Society. After tending to public duties, he opened his private notebooks and returned to alchemy experiments and careful reflections on scripture. These secret pursuits filled dozens of volumes, showing a restless mind always searching for deeper truths. In 1703, Newton's influence grew when he was elected president of the Royal Society. Though he rarely spoke at meetings, his steadfast leadership encouraged young scientists across Europe to pursue experimental research. Under his watch, the Society published many groundbreaking studies, and London became an even greater hub for scientific discovery. Newton's time in the capital shaped Britain's economy as much as its science. His reforms at the Mint secured the nation's currency, while his work at the Royal Society guided Europe's scientific dialogue. Through it all, he remained a private, thoughtful man, devoted equally to public service and personal study. Chapter 6: Newton's Final Days and Enduring Legacy. On a cold March morning in 1727, Isaac Newton felt the weight of 84 years settle upon him. His mind, still sharp with questions about nature and numbers, wrestled with the fragility of the human body. Friends and colleagues gathered in his London home, offering warmth and quiet conversation as his strength ebbed. As news of his failing health spread, the city prepared to honor its greatest scholar. Draped in somber black, Westminster Abbey awaited the procession that would carry him to rest. Thousands lined the streets of London in respectful silence, clutching candles and letters penned in gratitude for the truths he had revealed. Inside the Abbey, the funeral service wove together faith and reason, reflecting Newton's own fusion of science and spirituality. Leaders from the Royal Society read passages beside Christian prayers, celebrating both his discoveries and his character. When the choir's final notes faded, the doors opened to sunlight, an echo of the enlightenment he had brought to the world. Newton's death was not an end but a transformation. His laws of motion and universal gravitation continued to guide navigators across oceans, engineers over rivers, and astronomers beyond the stars. Each coin minted under his watch carried the imprint of his integrity, reminding every hand that held it of his quiet courage. Even today, students learn his principles by candlelight in classrooms around the globe. His notebooks, once secretive journals of alchemy and faith, now inspire historians to see science as a deeply human pursuit. Though Newton's voice fell silent, the questions he asked still echo, in every experiment, every calculation, and in the endless search for truth. Chapter 7: Life after Newton's death. When Isaac Newton died in 1727, his work did not rest in a dusty archive. Friends and colleagues at the Royal Society gathered his notebooks and letters. They published missing chapters of Principia and new essays on optics. Halley oversaw these editions, ensuring that Newton's ideas reached every corner of Europe. In the decades that followed, students opened Newton's laws like doors to a new world. Engineers used them to design steam engines, bridges, and canals. Navigators plotted ocean routes with greater confidence, relying on universal gravitation to guide their charts. Factories and workshops buzzed with machines built on Newtonian mechanics. Philosophers and thinkers wove Newton's vision into the fabric of the Enlightenment. They saw nature as a grand machine governed by clear, discoverable rules. Writers from England to France celebrated reason and experiment. Newton's insistence on evidence and calculation inspired the belief that humanity could solve any problem. By the early 1800s, mathematicians such as Euler, Lagrange, and Laplace expanded on his methods. They transformed calculus into a powerful tool for physics, astronomy, and engineering. At universities, Newton's texts remained at the heart of every scientific curriculum. Even when Einstein proposed relativity, he stood on Newton's shoulders. Today, Newton's influence lives on not just in textbooks but in every rocket launch, every satellite in orbit, and every digital animation that simulates motion. When students test gravity's pull or calculate an orbit, they follow steps first drawn by candlelight in Newton's study. His death closed one chapter, but the story of modern science marches forward in his name. Isaac Newton's life began in a small farmhouse and led him to the heart of science and public service. From his lonely hours on the farm to candlelit nights at Cambridge, he followed his curiosity with courage and care. He showed us that simple observations, like a falling apple, can spark ideas that change the world. Through Principia, Newton taught us how to use mathematics to understand nature. His three laws of motion and his law of universal gravitation laid the groundwork for physics and engineering. Generations of scientists, from Euler and Lagrange to Einstein, built on his work and carried his methods into new frontiers. As master of the mint and president of the Royal Society, Newton proved that a devoted mind can serve both knowledge and community. He balanced public duty with secret studies in alchemy and theology, revealing a restless spirit always seeking deeper truths. When he passed away in 1727, Londoners lined the streets to honor him. His state funeral at Westminster Abbey marked the end of a remarkable life. Yet his legacy lives on in every bridge that stands firm, every spacecraft that soars, and every classroom where students learn to ask, why? Thanks for joining us on Isaac Newton's journey. If you enjoyed the story, please hit the like button to let us know you found it helpful. Subscribe and tap the so you never miss our next biography adventure. Drop a comment below. Tell us which fact about Newton surprised you most or who you'd like us to cover next. Share this video with friends learning English or anyone curious about science history.